Can you see the slide, Christopher? Good, good. Now, uh, our wide area network and local area network. Local area network, so is geographically is covered the small area. Okay, small area meaning is that networking in our house, okay, or networking in a building, small building, not giant building. Okay, giant building is not possible. Let's say the World Trade Center. It's a giant building. We have maybe more than 500 or 600 networking system over there, local area network there. So small building, small geographical area. That is the local area network. And local area network, another is the one we discussed about this thing, three types of different types of networking. In we have one class, but I'm telling you again. So one is the LAN, local area network in general. Okay, in general we are saying about this. One is the LAN. I'm sorry, why speak? Okay, LAN, and then what is the LAN means local area network, and what is the MAN, metropolitan area network, and then one in general. Okay, wide area network. We have the other networking system also. There's like say the PN, personal area network, and then we have the other networking system that is called the uh, OCN. OCN. That is uh, exclusive. Okay, it's very interesting. OCN. It's this networking that is the on chip network. You know the microprocessor. What do you understand about the microprocessor? Is like this, something like this, and billions of transistors are there. Billions of transistors there, and all the transistor they're connected one with the other. All the transistors are connected with the other, one with the other. That networking, uh, there we can see the interesting network system. That is the on-chip network. And then uh, in the other, let's say in our motherboard also, we have the many circuits are there and many network systems are there. This also on-chip network. Okay, on-chip network, that is different thing. And PAN means the personal area network. Personal area network, that is the PAN, personal area network. So LAN, we are going to understand. In here, we are going to understand, focus more about the LAN. LAN, why LAN? Because if you understand LAN, then we can easily understand MAN. And then we can easily understand WAN. Okay? Why? Because MAN is many LAN together is the MAN. And many LAN MAN together is the WAN. Okay, so what is our uh, primary understanding? That the primary thing to understand, that is the LAN. To understand LAN, if we understand LAN well, okay, very good, then we can understand the man, then we can understand the one also. Here is some different with the devices. Okay, uh, here's some difference, structural differences we can see. The man is the metro, it covered the metropolitan area, and then one, it covered the wide area that is in the globe. Okay, globe, entire world. Okay, everything in space, everything, all communication in one, right? But one is nothing but collection of many local area network. Okay, so this is the cable, yellow cable, we can see it is called the RJ45 cable, RJ45 cable that you have to connect, right? Uh, that cable you have to connect, right? And we have the LAN card over here inside the motherboard, right? Inside this box, if you open this box, then you can see that we have a LAN card. LAN means that the LAN card, and uh, LAN local area network card. That one card is a network card is over there, okay? And then we can see the WLAN, wireless local area network, okay? Wireless, okay? WLAN card also there sometime if when you are going to connect wirelessly. Anyway, so these are the thing we are going to understand about the LAN networking. LAN networking, why you have to understand, focus more here. That is the many LAN together is the many LAN together is the man, and many man LAN man together is the one, right? And we have to understand here for the security purpose. What is the security purpose? Security means that the uh, attacker hacker, they hack our system, right? They try to do something bad, or they try to install something over here, uh, damage done, right? So since we are going to have help organization, institute, or company as engineer, so we should know very well networking system, and then the cyber security system also, right? So it does not mean that you have to learn everything, right? But we have to keep some basic knowledge. Okay, basic knowledge. Then install, troubleshoot, structured cabling. We are going to understand structured cabling, and then explain the basics of TCP/IP. TCP, transmission control protocol, and then the internet protocol. Okay, this we are going to understand, and install and configure the wired network. Wired network, okay, and then troubleshoot wired network. About this we are going to understand. And networking system, we have the uh, internet system, we have the other thing also. What are this wireless network that we can see? What are these that we have to depend on some devices, okay? actually Actually wireless network or network system, okay, networking or wireless internet, the thing we are saying is mainly based on the three things. Okay, based on the three things. Number one is the cabling structure, cable, okay, cable. Number two, is the that the we have the uh, router, okay, router, right? Router modem, okay, we need these devices, okay. So and then if we understand about these devices and their connection, then we are okay. We have to, of course, all we have to set up based on the software, right? Software, and based on the some protocols, rules. Okay, let's say the example of the rules are here. TCP, transmission control protocol, it's a very powerful protocol. It establishes host to host connection, okay, end to end connection. And then the another, we have the IP, internet protocol. The IP addresses, internet protocol. We should understand that, right? Every devices we have the IP addresses, okay. And then IP, we can see in the IP is a protocol that we can see in the layer, network layer. And then TCP we can see in the transport layer. Transport, that we have the how many layers we can see? We can see the seven layers. Seven layers. First one is the uh, if it's a seven layer, it's like this: 7, 6, 5, 4, 3, 2, 1, like this. One is the physical layer, physical. Two is the data link layer. Three is the network layer. Four is the transport layer. Five is the session layer, and then six is the presentation layer. Seven is the application layers. Okay, application layers or user, we people are here. Okay, interesting system. So these seven layers, In this 7 layer, we can see TCP. In the 4th layer, TCP. Okay, and then we can see the another layer, another one we found here, IP. We can see in the IP in the 3rd layer, IP. Okay, Internet Protocol. Okay, so these are the protocols. So what I'm saying, that we need some devices. Okay, we need some devices, and then these devices we have to connect one with the other based on some protocols. Okay, protocols. Okay, based on some protocols. Okay, and this connection we establish using some software, right? Installing software, then set up software, then uh, based on this protocol we connect some devices, and then we can share data, one computer to other computer. Okay, one place to other place, one country to the other country. That is the networking system. Okay, internet networking system. Here we are going to understand about this. Cabling, we know that the dominant networking technology, Ethernet. Ethernet. Do you know the Ethernet is the network based on the cabling? Okay, based on the cabling, Ethernet. And there we use the unshielded twisted pair. Unshielded twisted pair cable, we are using unshielded twisted pair, UTP. UTP cable we are using. And most common is the, that the RJ45. RJ45, I think we have a chapter in chapter 3 or 4 there we understand network devices, right? Visible network. In that chapter, we understand RJ45. And another one we know that is called the RJ11, right? RJ11. RJ11 is for the telephone, okay, telephone cable. RJ stand for register jack, okay. 11 it is for the telephone, and RJ45 is for the networking, okay, for the computer connection network, okay. This is called the Ethernet network based on the cabling system is the Ethernet. And what they said, RJ45 connectors are the most dominant form of Ethernet, but other cabling types include the optical fiber cabling and coaxial cabling. Okay, so cabling, what do you understand? Three different types of cabling. One is the uh, unshielded twisted pair cabling or shielded twisted pair cabling. That is the copper cabling or RJ45 or RJ11 cabling. Okay, one is the uh, RJ45 cable. Okay, or copper cable, simply copper cable, copper. And one is the optical fiber, and one is the coaxial cable. These three different types of cable uh, we have to understand well. Okay, we should know about this, and uh, we should know meaning is that the when you're going to do work, then we can see the networking system based on these three things. Wired, it is called the wired network. That is the we need the cable, and we have another network system that is called the wireless. There is no cable. We don't need, right? Let's say you have the Wi-Fi nowadays at home. Okay, Wi-Fi, or we can use our internet anywhere outside. Wi-Fi, we don't need to use the cable, right? That is the wireless networking. Optic fiber, okay, optic fiber uses optic fiber. Optic, what does it mean? Optic means that there's something related with the light, okay. Light, we are using the light as to trans we using the light uh, for signaling purpose, okay. We are using the light, okay. uh, Inside the its optical fiber is like the glass tube. Inside this tube we pass the light. That is when I'm talking, let's say I'm talking from my here to you, okay. I'm here, I is here, okay. I'm here, and you is here, okay. You is there, Okay, and I'm talking to you over the optical fiber. Okay, our communication based on the optical fiber, and through this fiber, inside the fiber, we are sending our voice converted as light. Torch light, a laser light, similar light going through this. Okay, through this cable, and that is our voice, our notes, our lecture, our information, data, everything convert as light and transmit. Why we have to use the optical fiber? Optical fiber is a very good reflector, and there is no energy loss. No energy loss. Okay, because here's the good reflector means that the all the energy going from me to you or you to me. Okay, there is the optical fiber. It's very interesting, and we are going to use the electromagnetic wave, that is the light wave, light. Okay, and specific 850 nanometer wavelength. Okay, 850 nanometer wavelength. The light we are using is wavelength. Wavelength stand by the we represent by the lambda, and it is 850 nanometer. Okay, nanometer and nanometer. 850 nanometer wavelength light we are using. So, hello, who is not listening me? Uh, my sound here. I think sound is okay. Okay, I give a maximum. It's okay now. We can hear you. Okay, okay. Maybe someone, please check device in your place. Okay, good. Please check sound system in your place because my system is okay. Sound is okay. Now the thing that what do you understand? We understand that here is a one I and there is you is connected with the optical fiber glass cable, and then I send the signal through it. Okay, a light signal. Okay, so signal means that my voice when I talk to you, then my voice convert to light signal and pass through this glass. And why you using the glass? Because glass is very good reflector. Reflector means that the no energy loss. Okay, there is no energy loss, and there we use the spatial wavelength. That wavelength represented by the lambda. Is this symbol is called the lambda. Okay, and it is 850 nanometer. Nanometer is too small, very very small, super small. Okay, so this wavelength signal, okay, wave we pass through this class, and then that signal carry our information, bias, data, everything. Okay, so that is the importance of the using the optical fiber. Optical fiber has no loss. If we can do the same communication by using the copper or coaxial cable, but there we can see the losses. Okay, loss means that we cannot listen clearly, data fail, and then the data drop, many things happen. But if you use the optical fiber, then it is something good. And this communication, optical fiber communication, is best for the longer communication. Longer communication means one country to the other country, one continent to the other continent. Do you have idea that we have the optical fiber connection under the ocean? Under the ocean, anyone here from Europe? Anyone here from Europe? I'm not sure. Anyone from Europe, Latin America, Asia? Okay, okay, Christopher. Okay, so no, so Europe, Asia, or Australia, or Latin America. Okay, we all the continent connected with USA by the optical fiber. Interesting. So how important it is. Look, under the ocean we have the optical fiber cabling system. Okay, I have a class optical fiber communication for the graduate. There I teach this thing. Is very interesting and the very important research over there. And then Wonderful. You know that we have the cable under the ocean. Can you imagine Atlantic Ocean, Pacific Ocean? Under this ocean, we have the cabling system. We are transmitting data. Okay, how data go from uh, USA to Europe. Okay, so we are using the optical fiber cable. Okay, that is why it's important to understand the optical fiber. Optical fiber cable is available in our lab. Okay, but you cannot understand, you cannot see. But today, after I'll show you some cable example, then you will understand. Oh, this is the optical fiber. But it's available means that we have. But the cable we can see in our lab, many cables we can see. This all copper cable, copper cable. Okay, and also you have the coaxial cable in our lab. Uh, After today lecture you can understand, oh, this is the, if you see this in class lab, then you'll understand, oh, this is the copper cable, or this is the optical fiber, this is the coaxial cable. Anyway, so even to electrical problems such as lightning, short circuit, and static. So there's many problem we can overcome through the optical fiber. Fiber optic signals travel further, much further, 200 meters or more. Okay, towards further distance you can transmit. Okay, like the copper cable, we can go 100-meter only. 100-meter. If we like to go maybe maximum 100-meter, then signal drop. So if signal drop is a problem, if we are let's say you are 500-meter far from me, so if you use the copper cable, then signal drop, you can never listen me. Okay, you can never listen my data. Okay, the data I'm sending to you. In that case, we can use the coaxial cable. Okay, coaxial cable is good for the 1 kilometer, okay, or more than 1 kilometer. But when we are going to communicate more than 2,000 meter, okay, um, or longer distance, in that case you have to depend on the optical fiber. Okay, good. Now most optical fiber networks uses the 62.5/125 multi-mode fiber optics cable. There we can see the different mode. Okay, MO3, MO4, MO4, MO3. These are called the category of the cable. MO4 is much better than the MO3, but it's depend on the environment. Is the short distance, okay, then MO3 is good. The longer distance, MO4, okay, like this. So which requires to cable, okay, and three of the more common connectors used in the optic fibers, and the SC, ST, and LC/MT RJ. So these are the connectors. For the copper, we are using the RJ 45, right, or 11. In case of the optical fiber, we are using the SC, ST, and LC/MA RJ. So these are the most common. Let's see, we have this figure here for these three things. Look here. Okay, this type of cable, you can see connectors. Okay, these connectors means that these are the optical fiber inside this. Okay, we have some connectors. Glass. Optical fiber means the glass cable made from glass tube. Then we have typical fiber optics cable with connectors. These are called the connectors, connectors, connectors. Okay, great. Multiple fiber uses the lead and transmit multiple light signal. Okay, multi mode means that when you pass the signal, the different signal, many lights you can see this plate. Okay, many lights, and all the lights never raise to the other end at the same time. Okay, for example, just yeah, I'm not because don't feel it as complex. So if you send the light, this is the source of light. Source of light means that let's say the laser, not laser. This is the source of light. This light, one light is going like this, using this path. One light is like this using this path, another is going straight. Okay, the light is going this path. I should use the a different color is better. Let's say this one. One is like this and going like this and then bounce back and then this. And this one is uh, let's use the other color, yellow. So this one is going there and then strike here and then comes here and then comes out, right? So look here. So since the light split and different light, different time reach, that is why it is called the multi-mode. Okay, multi-mode. So multiple reflection angle tend to disperse over long distance. Multiple angle. Okay, one is the straight. Okay, the one is the straight. Yeah, it's very simple. Let's say we have you'll have to go to the Manhattan. Okay, we have the 10 different path. All the path are not same, right? The path is the straight. We can go faster by using that path. Okay, and the path is too much bending. It takes a long time, right? But we can go there. Similarly, here the signals and all the rays are not reached at the other end at the same time, different time. That is why the name multi-mode. Okay, they said that they disperse over the longer distance. So multiple reflection angles tends to disperse over long distance. So multi-mode fiber optic cable are used for relatively short distance. Okay, multi-mode fiber cables are used for relatively short distance. Okay, so this is about the 600 meters. It is also slower. Okay, slower because it takes time, right? And mbps data is here, 10 100,000 mbps or some uh, or higher than this. Single mode fiber optic cable is the laser light. Single mode is the laser light. Keep in mind, multi-mode, there's the light source we are using. Okay, of course, intense light. uh, Anyone here, uh, do you know something we have special in the New York City? We have many things in this city. Okay, many special things we can see. One is the parallel beam. You can see World Trade Center. Beside the World Trade Center, there's a, at the night time, if you go there, please, if you go at the night time, especially we can see, mostly you can see just after the evening. Okay, evening, like say 8 to 9 or 10, like this, during this time we can see that there's a light. Okay, that light, two parallel light, is perpendicular, that is the to the sky. Okay, from near the World Trade Center. Okay, surrounding World Trade Center. So two light beam, very strong beam, and this is the place, that place we can see detect from the moon. Okay, this is the, at the night time we can detect this place from the moon. Okay, this light is very intense and very powerful. If you go that area evening, nighttime, then look in the sky, you can see that they, oh, it's wonderful. I enjoy it because I know it's how does it work. I know it's engineering. Okay, so it's really very interesting. So that spot we can see from very far. So this type of light, okay, we are using here. In case of the multi-mode and single mode, we are using the laser light. Laser light is the one color light, one color only. Okay, only one light. Okay, one color, one length, something like this. That is why single mode. Okay, and that single mode we use uh, uh, for the long distance. Okay, for very far, longer distance, single mode. Okay, wonderful. The major difference in optical fiber standards are the speed and distance limitation. Speed and distance limitation, and the way they interconnect. You must use matching fiber switches. Okay, what do you have to do? Matching is important. I told you in the previous classes also. Card, connectors. These are matching, must be matching. So we found the multi-mode optical fiber, single mode, multi-mode, right? So the thing we have to be careful that the while we are going to use the switches and then the card or the connectors, we have to, if it is based on the single mode optical fiber system, then we have to uh, use the similar thing that is supported by the single mode, not the multi-mode. Okay, that thing, that is the matching, we already know. That is our job. Our job is not to understand how the optical fiber work and how this wavelength form or how this is that. Okay, we have the other class for the other student for this, but we have to know, what we have to know, that we can design, develop network system based on the optical fiber too. Our optical fiber is a physical media that we can see in our network system. Okay, and then there we have to sometimes we have to replace the cable, sometimes we have to replace the card, sometimes we have to replace the switches, sometimes we have to replace the connector also. So that match on not, that we have to be very careful. We have to look for always that match as engineer, right? That is why we are here. We have a you may have a question, then why you are going to understand this thing. Optical fiber is not your part, I know that, but for the connectors cabling system we have to know, because we are using this for network means based on the computer. Okay, computer means, so it's our goal, right? Since it's our goal, we have to know that also. Another cable is called the coaxial cable. Coaxial cable. So UTP is the unshielded twisted pair. There is the copper cable. Copper cable. I told you that the one is the copper cable, one is the coaxial cable, one is the optical fiber, right? UTP stand for unshielded twisted pair. Okay. Primarily used now the cable modem and satellite connections. Okay, cable modeling system and satellite connections. We are using this thing, and coaxial cable consists of center cable core. It is the two part center cable, and another cable is in this surrounding. Okay, one cable is in the center and the other cables are in the surrounding. A very interesting coaxial cable structure, okay, that we are going to see in the next page. This in turn covered with a shielded or braided cable. So it's covered. All the cables we cover, well covered. Otherwise, why cover? You know that if you go during deep winter, if you go outside, we should wear the jacket. Otherwise, we crash. Right? Big problem. Here the temperature -15. In that temperature, if you go outside with a t-shirt, then we cannot back. Right? Similarly, we have to use the jacket for the cable also. Okay, we need some shielded cover. Why? So that this cable, I told you that this cable we are using under the ocean also, not only water, under the ocean, that is the seabed. Okay, in the seabed, this is the sea, something like this, sea. Okay, big giant ocean, here's the water, right? Water, and under this ground, underground, our cable going on. Okay, otherwise, the under in the ocean, many different types of animal means fishes. Sometime giant shark bite it, bite. I have the video that I have to discuss with my graduate student for this thing, that what problem we can see, what different types of problem we can see over there. And sometimes giant fish come and bite it. They're very strong fish, that's very strong and giant. This fish does not care anything. Okay, and then sometimes the soil move. Okay, sometimes too much soil come on it, sometimes soil leave, and then uh, it's floating only on water. Okay, this is also not good. And then sometimes many other things, earthquake is always randomly earthquake going on. So many natural uh, obstacle you have to keep in mind. Okay, when you are going to design this cable under the ocean, it's really interesting. Anyway, so that is why we need the cover. If we use the cover, then shark cannot bite it. Shark can bite. This can bite only over the cover, right? In the car, if the car body is strong, if small accident happen, we are fine inside the car because cover is good. Similarly, if the cover is good, then uh, cable, that is our data information, can transmit, or we can transmit. Okay, communication is good over there. Then otherwise, it's a problem, right? That is why we can found this cover, well cover. Look here, this is the coaxial. Okay, for short we are saying COX, coax. Okay, coax. So center cable, they say it's center cable. I said just before, and this is called center cable. And there is, look, another plastic insulation. It is called the insulator. And then this another cable. This is another cable. Okay, this cable is isolated from this cable. If these two cable together, then danger. Okay, these two cable together inside this coat, jacket, but there is another insulation one from other. Okay, another insulation we can see, that is the one from other. uh, why? For safety. Okay, if these two together is very strong insulation. Okay, any fault develop, there's big problem, right? But it will not. The substance insulator we are using is very strong. Okay, very good. Okay, scientific. Okay, it's designed scientifically, so it is good. And it is the lifetime. Okay, it is the life, that is how long, many years. Okay, many years we can keep this cable underground. You know, we have the New York City. We have many cables underground, under the road, under the many, under Hudson River. Okay, Staten Island to Manhattan, there's a big river gap or ocean, right? That there we can see this cable underground, under the ocean, under the river. So for the many years, but it's still okay, good. Okay, but salty water, very uh, too much decay over there. But uh, our cable is good over there because it is designed scientifically. It's not something like that. Go to market, buy and made and place. Okay, use. It's not like this. Scientifically designed. Anyway, so coaxial cable, we found that we have a cable, center cable, and we have another cable. Okay, these two cables separated by another insulation, and here is the coat. Okay, one coat cover. This cover is very strong. Okay, let's see more about the coaxial cable. Coaxial cable are rated using the RG name. Okay, RG name, and then primarily RG59 and RG6. Okay, RG59 and RG6. These are the category version. Okay, for different purposes you have to use this. You can see by the name. When the RGSC, when you see the SC means that it is optical fiber. Okay, if we see the RJ, this is the copper cable. Okay, when you see the RGG, then this is the coaxial cable, right? So these are the different standard for different purposes. Coax standard are rated by impedance. Impedance, in my engineering class I teach the impedance. Okay, impedance and resistance, like the same. Okay, it is opposite of conductance. One is the conductance, one is the impedance, one is the capacitance, one is the resistance, right? Resistor, capacitor, inductor. We have the devices in our electrical engineering class. We have to know this very well, their uses, right? Because all the circuit we have to design based on this. There, for the inductor, we can get the inductance. Okay, inductance. Inductor is like the coil, something like this coil, this type of coil. Inductor. Okay, have a 75 ohm impedance. Okay, impedance is 75. Is very 75 ohm means very low impedance. Very low impedance means the good conductance. Very good conductor. Coaxial cable, very good conductor, but optical fiber is the best. Okay, best. Coax most commonly uses two different types of connectors. A BNC connector uses a quarter twist connector and an F-type connector. Okay, BNC is one, F-type connector uses a screw connector. We are going to see in the next slide. BNC is uncommon, but F-type is on the back of all cable modems and most television. Okay, that we can see in the television. We have the nowadays we are using the smart TV. There we are not using the cabling system, but still we have the cabling system backside. Okay, if you go to the backside of the television at your home, then you can see this one. But the 10, 20, 15 years ago, we mostly use this one. Okay, this one. Let's see what type of cable, then you'll understand. Oh, this is the thing. Okay, we have that at home. Still, we have this at home. Well, I'm not using, but in my apartment, I have this. Okay, I have this one. BNC connector. Look here. This is the coaxial cabling system. Interesting. Okay, and F-type connector is something different than the BNC. It's the we have to plug in and then twist it and make it tight. It's okay, safe. Okay, and then look here. There's a central cable and there is a surrounding cable. Interesting. This is the F-type connector. Look, F-type connector. Okay, great. Now the hub. Try to understand the hub. How about the main interconnection for older Ethernet network? Okay, older Ethernet network. Interconnection, main interconnection. Hub means uh, like the center. Okay, center switch, something like this, center. Let's say Manhattan. This is the Manhattan. We have the Manhattan. Here's the Staten Island. Here's the Queens. Let's just suppose Queens. Here's the Brooklyn. And here is me in Bronx. Okay. And then we have the, what is this called? The New Jersey also. New Jersey also. Okay, New Jersey. So if you like to go Queens, then you have to go to the Manhattan. Okay, and if you like to go to the Brooklyn, then you have to come through the Manhattan, right? If you like to go to the Staten Island, then you have to go through the Manhattan, and then right. These are like the computer. All the computers, computer, all are connected with the hub. But this is the earlier system. Okay, many years back we used to use this hub, but nowadays we are using the hub. Behave is hub, but the other devices, including with other facilities. Anyway, any incoming signal on any port on a hub is recreated, repeated, and sent out on every connected port on the hub. So if I send some document to you, let's say I'm sending here, I'm here and I'm sending document to you all. You are for student or for different location. Then hub receive this one, and then it's check, and then the is a like the is check the signal is okay. If not okay, then fix it and send to the other devices like this. Okay. The downside of the hub is that all connected devices have to share the total bandwidth. Okay, however, extremely rare today, having been replaced by switches. Okay, switches. We heard frequently the switch, right? Switches. Before the switch, we had the hub. Good. This is the typical hub. Hub is like this, and these are the connection, right? The connection I show you, like they all connected with this is the Bronx, this is the Manhattan, this is the no, so this is the Brooklyn, this is the New Jersey, this is the Queens, or this is the Staten Island, right? Like this, all connected. Okay, this look like this. Actually, they're internally all connect with the hub, one with the hub. This is the connection port. Switches are currently the most common interconnection for Ethernet network. Okay, Ethernet network switch. Switch look like a hub, but switch automatically create point-to-point connection. Switch has some additional things. Okay, automatically create point-to-point connection between any two computers. Okay, by separating every connection, each computer can use the full bandwidth of the switch. Okay, each computer can use the full bandwidth of the switch. This is the switch. Switches look like this. If you go to our lab, computer lab, then you can see we have the switches like this. We have a switch. There is a rack, rack, like the bookshelf rack, and it's always locked because this is very important. And if any problem here, then a network problem, internet network problem, right? That is why we can see always the switch inside the. We have to lock the switch for security purpose. Hacker, what they do, they not only attack in, through the online, they attack physically also. Hacker come and they disconnect this, or they try to break this, or they use something to make permanent damage so that the network fail. Hacker, they different types of bad things. Okay, bad things. It's very interesting. Hacking is cyber security is another interesting thing. Cyber defense, cyber security, penetration testing, right? So anyway, in our case, what do you have to know? We have to know that about the switches. Why switches? Brace. Okay, brace. We know brace. There's a Brooklyn brace that connect Brooklyn and Manhattan, right? Braces. You can easily connect to Ethernet network that use completely different media internally, such as UTP and optical fiber, or maybe UTP to wireless using a brace. That brace is called the, do you know what that brace is called the access point? AP, access point, okay? Access point uh, or router, okay? Brace, access point, okay? Access point that connect the wired network with the wireless network. The bridge, what it does, if no Brooklyn bridge, then Manhattan people cannot connect with the Brooklyn. They may be connect with the other way, but the bridge help us to connect one with the other. Similarly, bridge will always have two interfaces, one for each of the different media. Each of the different media, one media is based on the cable, another is the wireless. Understand? It's very interesting. Just read this thing. And then this, here the typical bridge are like this. Okay, we are connected with the wireless here and the wire cable is here. So two network, one network is wireless, one network is with the cable. So how they interface, how they communicate? So you have to use the bridge. If you use the bridge can introduce one with the other. Okay, bridge, wireless network give data in one way, wired network handle data in other way. So how possible? through the bridge like this. Interesting thing, then network address storage, that is the NAS, network address storage. You can use a network address storage system instead of a server for file sharing, access, and network. Okay, and then NAS is basically a headless system, no monitor. It has no monitor, no keyboard, no nothing, no mouse. That you plug into a network. We just plug it. Okay, storage, storage. It stored data for a while. So we cannot see anything there. We cannot type anything there, and we cannot cursor click anything there. So what it does only one thing. Only one thing it does: share its hard drives. Hard drives, something related with the memory, right? Storage. Share its storage. Storage share. What stored over there, it's shared to the where it's need. Okay. Almost all NAS devices uses some form of web interface for configuration, enabling you to control the NAS from a web browser on any PC in the network. Just right, and let's see the image of this. This is the NAS. Okay, no display, no cursor, no nothing. It's like the storage only. It looks like something we can keep over there, right? Like this. And then we are going to understand the router, very important and very powerful devices, right? Very important and very powerful devices. The router, why do you use the router? Router we are going to use when you are going to connect one network with the other network for internet. For the network, we don't need the router. Network means you have the 10 devices, 20 devices, you can connect and you can share data one with the other. You cannot connect with the outside world. Okay, outside, you cannot communicate with me or your friend. If we like to communicate with you and your friend, then we have to use the router. Router is very important then, right? Router connect LANs. Okay, many LANs connect using the TCP/IP protocol. Look, TCP/IP protocol means that it's related with the router. Router must have at least two connections. It needs two connections, one into a network and one out to another network. Okay, and that is the one connect with the network, and other is the another out to the another network. This connect is in and then pass, or something like this. More powerful ones have many different connections. Okay, many different connections you can see. This is the typical home router. The router we have at home, something like this. Okay, so these are the PC connection, modem connection. Here we can look internet connection. Okay, modem, internet connection, and then the very PC, we can establish many more connection also through this port. And we have the other connection here also. Okay, this like this charger related. We have to charge also. Okay, connect to the electricity. Modem router when we place, then we have to connect with the electricity also. That is why if electricity fail, if no electricity, we have to keep this in mind because these are the engineering. If no electricity, then no network, internet. Okay, so if no electricity at your home, then you cannot use the Wi-Fi. You can use mobile Wi-Fi that is provided by the Optimum or Leica. Okay, but in the Wi-Fi at home, the connection we get from the Verizon give us the connection, or the Optimum. If electricity gone, then our connection gone. We cannot communicate, right? So electricity we need here. But nowadays we have the backup. If we have the backup, then we can use it. That is the different thing, right? We understand UPS, uninterruptible power supply, right? Can you remember? So these are for the backup. If you have the backup, then we can use it. So I'm not going here furthermore. Let's see here. Where is the other thing? So this is the structured cabling. Structured cabling is, look here, how to connect it. Cabling. So we all know how to connect it. You have the different devices, PCs, right? And then here is something, okay, we have the many port, connect with this and connect with that. It's very simple. We have the standard connectors, we have the standard cable, we have the manual, and just we have to connect. We have first, before connection, cable connection, we have to set up all of the introduce all the devices to the CPU motherboard. I told you in one class that if we like to add, if we want to get some extra benefit by using one device, that device we must have to introduce with the motherboard. We have to tell the motherboard, hey, motherboard, we have a new device, we like to play or do something, so please allow us. Okay, then motherboard connect it and then allow us to use it. Okay, all simple, just we have to follow the rules. Okay, rules, protocol. If we violate the protocol, then problem. Like if we see the red light and still we try to go over the red light, then problem. Problem many different ways, right? If traffic police see, then he will stop you and give you ticket, big ticket, and points also. Okay, and even they can uh, send you jail also if it is danger. And another danger, what type of danger it is? If we violate the red light, then other side car we can collide, right? Collide. Collision means accident, even death, right? So rules, if you follow the rules, life is simple. Okay. Here in the city nowadays, we can see in the globe, uh, very crisis, crisis going on. After pandemic, this is increasing crisis. Why? The people are worried. They lose their patience. They're not care anything. So they're violating many rules. So when we violate the rules, then there is the problem. If we are in rule, then we are okay. Okay, good. Telecommunication room is like this. Look how the telecommunication room is your desk, is your friend desk, is my desk, is hard desk. Okay, and then cable, how this cable come. Okay, and then it looks good. The design is like this. So engineer, we should keep this in concern. Okay, so let's say this computer has the problem. This computer has problem. Then what do you have to do? We have to find out that which connection, which cable connection from where. Okay, we don't need to come here. We can fix from the outside also, but we have to know that which one is connected with this. That is why you can see the server room, server place. This is used many connections are over there, many devices there, many storage there, many things there. But everything, there's a thousands cabling. When you go there, then it's surprising. This, oh my God, how to maintain and manage it. But if you follow the rules, it's very simple to manage and maintain it. Okay, good. And then this is another one, horizontal cabling system, work area. And then these are the thing. Now, structured networking, we are familiar with the category, right? This we discussed in our one class. Okay, category 5E cable or better UTP, horizontal cabling. Look here, horizontal cabling, the cable we are using this. 5E cable, 6 cable, 5 cable. We found the different category. Category represent the quality, right? Quality. So this we have to connect for the structured cabling. There is the in the workroom to make it reliable and easily manage and maintain. Uh, Structured cabling network component, more about this. All UTP cable come in one of two types. We already know that: solid core or standard core. Okay, UTP means that the unshielded twisted pair. In visible network chapter, we understand about this, about the copper cable. That's why I'm not talking too much, but I'll tell you something about this. One, solid core or standard core. Each wire in solid core UTP uses a single valid wire, only one cable. Okay, only one wire. In standard core, each wire is actually a bundle of tiny wire strands. So you know that the sometime all the connectors in the lab, if you have the lab in our school, when you go to the lab, then you can see the cable, only one cable. Okay, only one cable inside. And sometimes we can see the one cable, and from this cable, if we tear off this one, okay, if we tear up, then we can see the many metal we can see from one cable bundle. It's look like the one, but when you remove the cover, then you can see the many cables. What this they are saying. Look here, only one cable here. Solid and standard core UTP. Only one cable here. And here, look, inside is one, two, three, four, many, right? Many cables. So we should know their uses. Telecommunication room, you know that we have to consider many things, and we have to organize, okay, set up, decoration must be, we have to follow the standard. Okay, standard means that when you join in the company, then if you have to work in the telecommunication room, then you will see the one wonderful setup. That setup you cannot change. Okay, we cannot change. It's said keep as it is. Okay, and if they ask you to design one more telecommunication room, then follow this one. Okay, there we need the standard measurement. Okay, measurement, and then the what to read to keep the device, how to keep the device, and rack size. Okay, and we have the device, many different types of devices, their sizes. Okay, we have to design the racks based on this device sizes, and then their placement. Okay, one type of device we cannot keep with the other type. Okay, if it is not prescribed. Okay, all the devices we cannot keep together. We have to keep because there is a, what is this called, interference. We found this interference in one class. So interference are the one is interrupted by the other signaling, so we have to maintain some distance gap. Okay, and sometimes we have to hang on the wall. Okay, mounted on the wall. Sometimes we have to keep in the floor, right, like this. Central component of every telecommunication room is one for or more equipment racks. We know that racks, which provide a safe, stable platform for all different hardware components. That I told you that if we use the rack means that the specific is a device specific place. It's like the uh, if you think that the hotel, okay, there is no room. It's a big hotel, no room, then it's a problem. Okay, one uh, one with the other, collision problem, many problem. You cannot sleep because other one talking. You cannot sleep other one showering, right? And many bad things. Okay, many things. Okay, not bad thing, but they're moving. Some are dancing. Some are talking. Some are eating. But when we live in the individual room, then we can do whatever we like. We are safe. So telecommunication room also like this. Okay. So if you keep everything open, then one is interrupted by the other. We have to use the racks, standard measurement there. Okay. They said all equipment racks are 19-inch wide, but they vary in height. Height varies, width is same. Okay, height varies, width is same. So what we understand that the while you're going to handle the devices, then we have to know which device in which room in the rack, which racks that we should know. Okay, so you can mount almost any network hardware component into a rack, including rack mount servers and UPS, etc. So this is the rack, and then we can design it. Okay, we can design, and then we have to keep the devices look like this. Okay, a rack mounted UPS is there on the rack. So I'm not going further. Let's keep up to this. uh, UTP, more about the UTPs. Telecommunication room, more about this. Okay, all rack mounted equipment uses a height measurement known simply as UAU. Okay, these are the symbol we can see over there is 1.75 inches. 1.75 inches is not too much, right? We can understand. And device also nowadays is getting smaller, right? A device that is fit into 1.75 inches space is called a 1U. The 1U, what do you understand? Device that is 1.75 inches device fit into the space in the rack, that is called the 1U. Okay, another device is 3.5 inches space is the 2U. And a device that is goes into a 7 inches space is called a 4U. So mostly we can see 1U, 2U, and 4U or 4U. Okay. A patch panel is simply a box with a row of female connectors. Patch panel is another thing, female connectors. Female connectors, we know that receive, okay, that where we plug in, right? In the front of the permanent connections in the back, to which you connect the horizontal cables. More about this, the most common type of patch panel today uses this special type of connectors called the 110 black, or sometimes 110 punch down black block. So UTP cable connected to a 110 block using a patch panel tool. UTP. UTP, unshielded twisted pair cables connected to a 110 block using a punch down tool. Patch panel are used for securing, organizing, and leveling cables. Okay, patch panels, why? That for securing, organized, and leveling. Okay, we can keep level also. This cable is there, this cable is there, this cable is there, like this. UTP patch panel, like the UTP cables, come with a category CAT rating. You know the CAT rating, category rating 5, 5 is 6, right? We understand, which you should to check the CAT rating of the patch panel must match that of the cable to which they connect. Look here, typical patch panels. Punch down tool. Okay, this tool we can use. Okay, punch down tools. We are fixing like this. This tool is available in our lab. Okay, if you like to connect with the connect cable, okay, then we have to use this one. It's very tightly and very simply we can do that. Okay, punching down a 110 block. Okay, 110 block for the UTP cables, right? We understand. It's like this. These are the tag leveling, writing, handwritten. If it's written, then you can understand quickly. Oh, I did this type of work here, or this connection is with that computer, or this connection with that router, or some other devices. Okay, interesting. So that is the one thing. I'm not going further for this topic. Please read up to this from here. RJ45, we understand. Cabling system. Look, this all the category 6 based the cable patch panel, and this is the cable, the RJ45 cable. We know, right? So from here, please read up to slide 44. These are the devices. Okay, crimper and snipes. Through this, we can open the cable and we can place it on the panel. Okay, if you like to place it here, then we have to open, right? Before going to the connector, we have to this. You do know that this all we can open. I'll separate it. These are separated. We can remove this one easily. Actually, when you buy the cable, then you buy the solid cable. Then we have to use the this device, okay, to cut it, and then we can. This is the connector. This is the connector. This is the cable. It's another connector. Okay, interesting. Uh, if you go to the uh, server room, then you'll see this type of thing, and you'll get the standard toolbox for this. Look, by after cut, all the cables look like this. Can you see this one? Look, after cut, it's like this. So, and then inserting individual strands, insert it, then done. We can create it, right? Something, and then use the plier, punch it, then set. Look, we set it this one. So it's very simple. Okay, it's very simple. Anyone can do, but we have to do very carefully. Here's the different cable. This inside you have the many different cables. Okay, it's separated cables. We have to keep separate. If we connect with the other one by mistake, then problem. It will not. It will no longer work. Problem then. Okay, we can buy the cable, and we can separately we buy all things, and we can create like this. So this is the thing, typical tester. Okay, after design this one, then we have to test it. This cable is okay or not? Is any fault developed or not? Any cable mixed with the other one or not? Okay, that we have to test. After test, if you see the green signal, okay, if you see all green signal for all the cables, okay, then this cable is ready to use. Okay, we designed, we built something, and then we have to test it. Okay, like that the food quality. First time when new food launched, then they test in the lab. If they found that all is good, okay, then make cakes. How many you can want, make and sell. Something like this. So you have to test it first. If this device says that your cable is good, your design is good, then we can use it in our lab or we can sell it. So let's keep up to this. I'm not going furthermore to this. Now I'm looking on the one thing, security issue. TCP/IP. I have to give you an idea about the TCP/IP2. It's very important. TCP/IP. Did I discuss this topic in any class? In any class? No, right? No, no. We should know the TCP/IP. These are the protocol. These are the protocol, transmission control protocol, and IP is the IP Internet Protocol. TCP we found in the transport layer, and IP we found in the network layer. Network layer. Just few slides I'll discuss. I'm not going in depth for this. The transmission control protocol, Internet Protocol, is the primary protocol of most modern network, okay, including the internet. So PC to access the internet, it must have TCP/IP loaded. I told you that if you're not this thing, that PC you cannot use for networking. Okay, we have to go through TCP and IP protocols. Without this, if we do not load this in your computer, that computer we cannot use in the network, in for in the for the internet purpose communication. Okay, it's very important. TCP/IP has become so predominant that most network faults use it, even on network that do not connect to the internet. It's very important. Okay, just read this thing about the TCP/IP. I'm going to say, I discussed about the IP, right? I discussed about the IP, how to create the IP addresses, right? Christopher, Zaden, Zoana. How the IP address, how the MAC address we discuss in one class. Okay, that is in chapter 3. There's the visible network. There I discuss about the IP address and network. Okay, so just read it. We found it here. Just read it. Okay, good. Yeah, but if you have any question, then you can discuss with me now. I can help you. IP addresses, and then I'm seeing what about the more about the. You don't need to come here. Just have to IP address up to this. You just read. Okay, up to this slide. Up to this. You read only up to this. 0 to 255. Do you know why 0 to 255? That I discuss with you. Again, I'm going to, this is the technical part. Again, I'm going to tell you 0 to 255 means that the IP address is, do you know how many bits? IP address is 32 bits, right? IPv4. IP version 4 is 32 bits. 32 bits, how many segments? 4 segments. 1, 2, 3, 4. Okay, 4 segments. Each segment is 8 bit. Okay, here is 8 bit. Here is 8 bit. 8 plus 8 16, plus 8 is 24, plus 8 is 32. 4 segments, and each segment is 8 bit. 8 bit means 2 power 8. 2 power 8. 2 power 8 means 256. Then you may have a question, hey Dr. Ghazi, if 26, then why is the mention at 255? Actually, we count from 0. Okay, 0 to 255. How many numbers we can see here? We can see at 0 to 255, meaning is that we can see here 256 number. We count actually from 1, but here start from 0. That's why it goes up to 255. Okay, let's say 0, 1, 2, 3. How many operation here? 4 operation. Look, 1, 2, 3, 4 operation. Actually, we wrote here up to 3. So because we started from 0, but that is why 4 operation, but we started from 0. That is why we can go up to 3 like this. Anyway, so you can never have an IP address. They were the saying that ends with a 0 or 255. Okay, 0 means it's never end with a 0 or 255. Okay, that is all the all bits. I said that each segment is 8 bits, right? 8, 8, 8, 8. All the bits never be 0, 0, 0, 0, 0, 0, 0, 0, 0, right? 8 bits never 0. Or 8 bits never 1, 1, 1, 1, 1, 1, 1, 1, 1. It's never 1. That is the thing they're saying. It's never all bits 0. It's never all bits 1. Their combination, any bits in between. 0 to 255, any bits in between. Interesting. Uh, don't confuse. It's a really very interesting thing. I'm not going further. Let's give up to this. Only one thing I'm going to tell. Then I need a gentle break. I have to drink coffee. Okay. And then I have to talk. Uh, what is that thing? There is the network, typical network, how the network look like. We all know, right? There is the switch. And this is the IP addresses, IP address, IP address, IP address, IP address. Every devices we need the IP address. Okay. If we want to, IP address means that the address. If no address, we cannot detect. Okay, we cannot detect. And then there is another one, that is subnet mask. Okay, I'm not going there. Subnet mask to detect the which section is for the network, which section for the subnet, which network, which section is for the. We found the 4 sections. I draw here 4 things, right? 4 segments. So in the network system, we can see the network part, subnet part, host part. Now, which part is for the host, which part for the network, which part for the subnet, that we can find by using the subnet masking. Okay, subnet mask. That we can find through the subnet mask. Okay, I'm not going in depth. Just keep in mind why the subnet part, to understand which part network, which part is for the network part, that we can understand, we can detect by using the subnet. Okay, I'm not going further. TCP or TCP, here the TCP. TCP and UDP is a datagram protocol. I discussed this thing in that chapter. Anyway, so use a datagram protocol. So their job is similar job. This job is similar. TCP transmission control protocol, UDP use a datagram protocol. The job is similar. Okay. Connection oriented protocol, I told you that the end-to-end connection established through the TCP and UDP. When moving data from one system to the another, TCP IP protocol, so it need to know if the communication is connection oriented or connectionless. Connection oriented protocol use the TCP IP is called the transmission control protocol. The connectionless one is called the user datagram protocol. Connectionless is the user datagram protocol, and connection oriented is the transmission control protocol. Most TCP IP applications uses TCP instead of UDP. Okay, good. About the 95%. TCP is very important. Okay, just keep up to this. I'm not going further. It's too much. So what you will read? You will read up to slide this. Okay, 172 only. Don't go beyond the 72. Okay, and then you'll get everything by this. After that, this connection we don't need to know. If you can read for your career, for your development, because you know the everything is learning is unlimited. If I give everything, then you cannot revise, you cannot write answer in the exam. So that thing I should keep in mind. Just I'm looking the troubleshooting. IPv6 is another one. IPv6 is nowadays mostly we are using the IPv6. One is the IPv4. I told you the IPv4. IPv4, it is 32 bits, and IPv6 is the 128 bits. Interesting. Okay, 128 bits. Okay, similar job. Why we move from IPv4 to IPv6? Because IPv4 is about the 4 billions connection devices we can use. Only 4 billions addresses. 4 billion. And IPv6, but in the globe we have the many devices. We have the more than 4 billions devices only in USA. Much more than that. Okay, because we have many devices. Like say how many devices I have at my home. I have in my desk. I have the four laptops, and then one desktop. I have two iPhones. Okay, and then I have in my reading room, living room, I have the another desktop, and then I have the laptop for my son. He has the two laptops. School give one, and I give him one. And he has the phone, and his mother has also the laptop desktop. Okay, so you look in one house how many we are using. Every house is same, and some houses much more than me. Okay, how many devices I handle? I have four chambers. Okay, I have four chambers, except my room, this room. I have four places. Okay, so everywhere I have the more than devices, more than two, three devices. And every lab, you know that the many labs, every school we have the many labs. And every lab we can see the many devices, computers. So billion is very small number. That is why we moved to IPv6. IPv6 means trillion. Can you understand? Zola trillion is how big it is. 1,000 billion equal to 1 trillion, right? Something like this is big. Trillion. IPv6 give us the trillion. Trillion. It's a huge number that is uncountable. Whereas the IPv4 give us the 4 billion. It's too small. But when the scientists first work with the IP addresses, they thought 4 billions is too much, right? That time. I'm not sure that the day will come that they will see that the trillion address is also limited. We need more. We want more, something like this. Okay, good. Anyway, I'm not going. Just keep in mind the IPv6 is like something like this. Uh, that they 128 bits, and it is the IPv4 is dotted decimal notation, DDN. Did you see the IP addresses? Dotted decimal notation. Dotted decimal notation is where we can see this one. Look, this is the dotted decimal notation. Symbols are 169 dots, 254 dot, 0.1. So dotted decimal notation. It's wonderful, right? So this is the IPv4, and it is decimal, means that the IPv4 address is based on the decimal number. Look, 169. We can read these are the decimal number, but the IPv6 is hexadecimal number. Keep in mind, IPv6 is based on the hexadecimal number. Hexa number. Look here, hexadecimal number. Hexadecimal number. Between 0 to F. Okay, so IPv4 is the decimal number. This is the decimal number. Look, we have the decimal number here. We can see here also. This is the IPv4, 32 bits decimal number. But the IPv6, it says hexadecimal number. Okay, hexadecimal number is the number 0 to F. We have to use the 0 to F numbers to represent the hexadecimal. Look here, 0F, CF, F came. Maximum we can go F. Start from 0 to F, all the numbers you can see in between this. These are all hexa number. Okay, 32 bits. Here is how many symbols? 1, 2, 3, 4 symbols, right? Each group, how many group? 1, 2, 3, 4, 5, 6, 7, 8 groups. In each group, how many symbols? 4 symbols. 1, 2, 3, 4, 4 symbols. 4 into, and each symbol, let's say 4 represented by the 0, 1, 0, 0. Okay, that is the 4. How many bits here? 1, 2, 3, 4. For every symbol, 4 bits. How many symbols here? 32. 32 times 4 is 128. It's a wonderful calculation. Okay, I'm telling you again. Let's say this is 0. 0. We found the 0. 0 is a symbol here. This 0 we can represent 0, 0, 0, 0. Okay? 4 bits here. 2 represent. Okay, I'm explaining 1 in detail. On the 1 I'm explaining in detail so that you can understand how 128 bit we can organize simply. 2 meaning is 0, 0, 1, 0, 0. 2. That is the 0, 0, 1. 0 is called the 2. And then you have the 0. 0 meaning is 0, 0, 0, 0. And then you have the another 0. 0, 0, 0, 0. And then you have the 1. 1 we can write here 0, 0, 0, 1. Understand? These bits, how many bits here? Here is 4, here is 4, 8. 4 plus 4 is 8. Another 4 is 12. 12 plus 4 is 16. So here is 16, here is 16, here is 16, here is 16, 16, 16, 16, 16. If you add all 16, then 8 times 16 is, if you multiply, then you can see 128 bits. Interesting. Okay, that is about the IPv6 addresses. Okay, if we are not in IPv6 address, if scientists did not find this one, then to get connected with the internet, you have to pay $1 million even. So we cannot use it because it's simple. Let's say we are 200 million. How many people are living in the New York City? 20 million, right? 20 million. If we have the 5,000 houses, then house is difficult to get the room to live. And then price will hike, okay, abnormally increase. And people will buy, the people can buy, they'll live here, other people has to leave the city. Similarly, if the scientists cannot find, they could not find the IPv6 address, then we have to pay huge money to get connected with the internet based on the IPv4 address. Otherwise, drop. No internet. We cannot use internet. Okay, so it's lucky that we found this one. And in future, I will see that again it is going to end finished. Then we'll try to find scientists try to find the other one. That's why I'm trying to inspire you. Let's focus more on our study. Try to do something new. Try to create something, design something, and sell in the market. You can be a billionaire even. You know, the Uber is a software billionaire. Airbnb software billionaire. Okay, GPS software billionaire. All are billionaire. So try to find some new things so that you can use and you can be a billionaire, millionaire. Okay, forget billionaire. If you millionaire, then it's good. So that is why you are very young. Your talent, you have the brain. Your talent. Try to use your brain. Not only focus on the part-time work. Okay, we must have to do the part-time work, but we should. What is this called? We should focus more on our study. Try to build some. and then sell in the market, can be a millionaire easily. Okay, these are the some example. We have the many different types of apps, many different types of software, many different types of hardware. Okay, many path we have. Use any one for a better future. Anyway, you're very young, so if you try, you can do. So this we understand. I'm not going further. Let's keep up to this. Just only one thing. That thing is the installing NIC. NIC. I introduced this one in the visible network chapter. NIC meaning is that network interface card. Okay, if we want to connect one computer with the network, then we have to use this card. I said about this thing. This installation, we should know how to install it. We have the guideline, follow this one, install it. And how to do that, disconnect all of the connection, place in the proper port, okay, and then lock it and tight the switch, the screw, okay, tight it, and then close the cover, then connect it, put all of the connect and switch on, okay. Install, uninstall. Similarly, we must have to disconnect the power. Why power? Because power is danger. Okay, installing the NIC. Why NIC? Otherwise, we cannot connect with the internet network, right? That is why we should know how to connect it. As engineer, you should know it very well. Okay, good. Okay, so give me 15 minutes, take a 15 minutes break. After the break, I'm coming here. Then we are going to discuss about our final exams. Okay, final exam, what we can do, and then what is due to post for you in the Blackboard. So please let me know what I have, I'll give you. Okay. I told you in one class, I can do many things for my student. Okay. If you want any help, I'll do. If you try, I'll help you always. Good. Then take gentle break for the, uh, please come by 7. Come by 8. Okay. 8. No, 8, 8, 5. Come by 8, 5. Okay. Come by 8. Come by 8. Okay, so the thing we are going to discuss now is about the final exam. Final exam, uh, okay, final exam is, I'm not going further about the notes. Troubleshooting, just the thing we know, just read it. Simple thing. Troubleshoot. I already discussed when I discuss topic. So let's move to our final exam activities. I'm looking one blank page where I can explain something. Let's go back. Okay, let's use this page. Final exam. There is in the final exam, you can see the exam. Exam, it is the two part. One is the section B. Okay, B. What is the section A? A is about 20 to 30 questions. 20 to 30 questions. Okay. And B is about two questions. Two, only two. Two for 20 points. And if it is 20 here, then 20 points. If 30, then 30 points. I'm not sure because I have to check that. So these are the 20 short questions you can see, or complete answer like this. You are used to about the midterm exam and then the quizzes also, and homeworks and quizzes, and then the midterm exam similar, right? Same question. So 20, and then here is the 20. If here is 20, then 20 from 50. If 30, the 20, 20, 40. If 30, then 50. Okay, this is the final exam. I'm going to write in detail. Okay, in detail. Two section, and exam is online, and it's the class time. Our class time, you can submit late, but it will affect your grade. Okay, you can submit late, so it will affect your grade, and next day submission will consider as absent, that is fail. Okay, next day submission will consider as absent or fail. So please focus more on the exam time. But the question I'm going to give, it is enough for 1 hour 30 minutes. It's enough, but you'll get 2 hours 30 minutes. Okay, about 2 hours, more than 2 hours you'll get. Okay, so it's easy and simple, and try to understand and try to read notes, not copying. Okay, copying we have no option because there is the online system is a disadvantage is that the student are very relaxed. They try to copy, not try to study. So if you study, if you understand, it's good for you, for your career. If you copy, it's bad for your career. You can never get a good job. Okay. In our time, thick book. When I undergrad student, I read complete book. Complete book. Whereas in your time, from this book, we select 4 chapters, and that 4 chapters we give the notes, we give the many presentation, and still you're not interested to read this. Whereas in our time, we read the complete book, right? So that is why if we want to get something or grab something good, then we have to understand. If you understand, it takes time. Every week I give one chapter. It's enough. Today practice 2 hours, 20 slide, tomorrow 20 slide, and 30 slide. Is 70, hardly 70 slide, 3 4 days is enough. Okay. So please try to understand and write from your understanding. Okay. Online exam, and then the time I'll mention, date the next week, and then I have to prepare your grade soon. Okay. So my date is with you maybe 20th. So 20th, yeah, 20. So 22nd is the last date. So I have to post your grade also. If anything due or anything, please submit by next 2 3 days, because I cannot do, because I have to work for your grading. Okay, I have to look for your grading. I assigned some labs, right? Labs I assigned. Practice all the labs. Okay, and then I submitted quizzes also. Many conducted quizzes also. I'll prepare your grade based on the quiz, midterm exam, and final exam, class attendance. Okay, these are very important things. And now I'm going to take your attendance. Please let me know one by one what you need during the present attendance. Let me know. If anything, please let me know. Okay. Any help? If you do not understand anything, if you need extra time, please let me know. I'll give you time. Cedron is here. Cedron. Thank you. Do you have any question, please? Do you have any question? Good. But stay in the, you can see that I'm going to just after the attendance, I'm going to post everything in the Blackboard. Okay. If any issue, please discuss with me. And questions, thank you. I don't have any. Good. Okay, thank you. Then Christopher is here. So Christopher, any question, please? No question. Okay, no question. Great. And then Collins. Oh, no, before the Collins, you have the Clayboy is here. Clayboy. I'm sorry, Collins. Wait. Clayboy is here. Barnes. Oh, okay. Collins is here. Can you reopen lab 2 4? Oh, lab 2 4. I reopened in the last week. Then why you did not? Lab 2. Lab 4 I reopened. Anyway, I'm going to do it again for you. But it is for 2 days only. Everyone, 2 days only. I'm going to reopen lab 2, lab 4, lab 5. Okay? Only for 2 days. It's simple. Okay? Good. And then anyone here? Collins. Reopen just 1 second, please. I'm checking. Lab 1, lab 2, lab 3, lab 3, 4, 5. Okay.
Professor,
Yes.
did I just hear you said lab 5? There
Lab
was a
5
lab 5?
means no. Lab 5 means that the no lab 5 here is
You said lab 5, so I was like, wait, I know there's a lab 4.
no lab 4. Okay, lab 4, not the lab 5. Lab 5.
There's no lab 5.
Yeah, no lab 5. But we conducted 2 more lab with the lecture. That ignore that one. Okay, ignore that one. But submit this full. Okay.
Yeah, I already submit all the labs already. You said lab 5, so you caught me off guard.
No, lab 5. I reopened the lab 3. It's look like lab 5. But I
Lab
conducted 2
3
other
and
labs
4.
also.
It's only 3 and 4, yeah.
Yeah. So 3, 4, 2, 3, 4, right? 2, 3, 4.
Yes, yes, yes.
In the system 2, 3, 4, and we did 2, 3 labs with the lecture that we already done. That we don't worry about this. So content is this. So I'm going to the great system. Here is the. Would you please switch off your sound, please, someone? I'm saying that the lab 1, 2, 3. Okay, some students submitted, some very few students did not submit it. Okay, so I'm for them. I'm going to reopen all of the labs for 2 days only. Okay, 2 days. Please practice and submit this thing. And then the next is Collins is here, right? Collins is here. Okay, and 3. Okay, 1 and 3. Okay, good. And then the Isabella Rosa. Do you have any question, please? Oh, no. Okay, good. And then if any question, please email me. And when you email, make sure that you are using the CityTech email. Okay. My name at citytech.edu because I belongs to many other school. Okay. And I'm going to engage with the another virtual system in the CUNY for the cyber defense. Okay. That is very interesting. That is the virtual. Okay. For the uh, not only school student, it's for the whole world people. And it's very interesting project we are going to run. That is the different thing. But while you send me email, make sure that you are using my CityTech email. Okay. And then the Isabella Rojas is here. Okay, fine. And then Zaden is here. Wonderful. Zaden is here. Zaden also here. Okay, good, great. And they have no question. And then we have the Volkov. Volkov is here. Great. Any question, please? Volkov? No. Zoana? Zoana is here? Okay, here. And Zoana say to open the floor, I'll do for you. Okay. And Minda is here, right? Minda? Minda. Minda is not here. Okay. And then Roito. Great. Roito. Roito, do you have any question? Oh, okay. Court Livia, do you have any question or you can enjoy your day? Okay. Is Court Livia here?
No
Court
questions,
Livia?
Professor.
Okay, then please enjoy your day. Okay.
All right. Thank you.
And thanks for joining with us. Interesting. Okay. Have a nice
Yep.
vacation. You all have a nice vacation. And the
All right. You
student I'm
too.
going to
Thanks.
discuss with you in the next class. Okay, because you have the exam, then I can discuss about the vacation.
Okay.
Okay, fine. Take care. Okay, Court Livia.
Yep.
Okay,
Bye.
bye. Right, and then the Baldono.
Yeah, here, Professor. So it's like in this class will be the final, correct?
Your next class is a final exam. Okay,
Oh, okay,
I'll be in
okay.
this. I'll be for 30 minutes. I'll be here with you, and then you have to sit for your exam only on the day. Minda is here. Minda.
Okay, have a good day, Professor.
Okay, you too. So I found you all of you. So I missed anyone name here? No. Clayboy Bernice is here. Clayboy. No. Okay, since you have no question, then let's enjoy your day. I'm going to post your other notes now. Clear?
Okay,
Thank you.
Professor.
I think I'm going to post your last class lecture notes and today lecture notes. Enjoy your day. wonderful summer. Thank you. Collins, any question?